Okay, so I'm going to go over some concepts that I think will help Web2 developers wrap their mind around the things that are needed when they start developing in Web3. So this isn't going to be technical. There are many ways to do things technically. So these are just going to be concepts for Web2 developers to wrap their brain around. Before I do that, though, I want to say why. Why would we start working in Web3? Because we enable data ownership. We enable digital cash. We expand the definition of what digital cash is because these small, tiny bits of money can become commodities as they carry data. As they carry data, metadata, etc., which enables things like micro streaming, micro payments. We also minimize the use of middle operators, aka middlemen. As we see in the internet today, there are so many rent seeking middlemen. And what we know about BSV technology is that it solves a lot of those problems. All right, so these are the 8 concepts. I'll go through them quickly. I call them fundamentals for Web2 developers, things that they are not used to understanding. And all of these 8 concepts will somehow be integrated into your development. It's not necessarily in this particular order. And they're certainly not all individual files. And lastly, I'm not talking about how this will be done or where this will be done, but it will be integrated into concepts that you already use in Web 2. All right, so the root of trust is the first one, and this is where the long-lived private key is kept. This is the base identity of the user or of the app or even perhaps of a device. Say it's an IoT device. A web developer's mental model for this, you can think of it like your API secret, an OAuth private key, or maybe a service account key, except in Web3, it belongs to the user or issuer, not the platform. A real world analogy, it's like the deed to your house and it's stored in a safe deposit box. So you don't carry it around, but it's the ultimate proof that you own the place. So your keys, in Web3 application, you load and derive use keys. So you take that long-lived key and you produce a short-lived key from it used for just one task. If it's paying somebody, if it's writing data to chain, etc. This protects your master key from exposure. So a Web2 mental model, it's similar to creating a short-term token from a master secret. So you never expose that master secret. A real-world analogy here, like getting a day pass from your annual membership. You flash the day pass, but your membership card stays in your wallet. The third concept is the transaction build itself. So you're preparing the action that you're about to take. This includes your inputs, your outputs, any data that action might need. A Web2 mental model, you could think of it like creating a request body for an API call. But here, you're creating a signed action that anyone can verify later. So it's like when you write a check, you fill in who gets paid, how much, and from which account before you sign it. So the fourth concept is signing. So you're authorizing that action. So you're going to prove that this action is allowed by using the private key. Nothing goes anywhere until something signs. And in the Web2 mental model, you could think of it like signing a web hook with HMAC or issuing a JWT. But here, the user signs, not the platform. So a real world analogy, of course, it's like signing that check at the bottom. It is not real until your signature makes it so. Next, we have the broadcast. This is when we send it to the network. So you're sending that signed action to the blockchain so it can be accepted and recorded permanently. So the mental model for Web2, you could think of it like making a post request to a third-party API endpoint, except it is going to the public blockchain, not on a company server. So this would be like dropping a signed letter into the post office box and it's gone. You cannot get it back. The next is called the callback, and this would be a confirmation response. You hear back from the network when the action is accepted, or perhaps it fails. And so you know when your transaction is confirmed. A Web2 mental model, it could be like a webhook or maybe an async job finishing. The chain through your broadcast service tells you that this is now confirmed. That's a callback. So it's like getting a delivery notification. Your package has been delivered. So UTXO tracking is also a very important concept in Web3 development. You are managing your coins. You're keeping track of your spendable outputs. So each output can only be used once. When you spend it, it's consumed entirely. If there is a leftover value, you get a new output back as change. And if you spend the exact amount, it's simply gone. So this is very different in Web3 development, and you have to have some way to track all that. So you could think of it like tracking inventory rows in a database where each row can only be used once. When you use it, the row is deleted. And if you didn't need the whole thing, a new row is created with a remainder. That's called the change. Anyway, that's all part of managing your UTXOs, also called coins. So in a real world analogy, you can think of it like having bills in your wallet or your purse. So you have a 20, a 5, 2 ones. When you buy something, you hand over specific bills and you get new ones back. So the last concept is called read and verify. This is public proof. So anyone can check that action on the chain, and your application will want to have a means for doing that. You want to confirm that it exists and confirm that the signature matches the signer. So in Web2 world, you could think of it like checking logs, but the logs are public. It's really what's cool about a public blockchain. So a real world analogy would be like a transaction published in a public newspaper that can never be edited. So anyone can look it up and everyone sees the same thing. So those are the 8 concepts that I've come up with. You can let me know in the comments if you have questions. And anyway, happy coding. And if you're new to Web3, welcome. The BSV blockchain is here for you.
Laid out clean with the point named G and a math machine. Pick a secret number, that's your key. Multiply G, now the public can see. On the curve, can't fake what you sign. Private stays yours, public looking fine. No prime cracks, no factor spin. We keep it all locked with the number in. N sets the bounds, keep it in line. G walks the curve like it's right on time. Private jet gets